What if we wanted to find the point of intersection between a plane and a line? Now you can see this plane I have drawn out over here, and you can see this line, and you can see they intersect at a point. You see this little red point that I have highlighted there. That point is what we're interested in finding. Now, in order to find that point where these two things intersect, we have to know a bit of information about each of them. We need to know the equation of the line. We need to know the equation of the plane. So the equation of this green plane here is given to us as 2x plus y plus 3z plus 1 is equal to 0. This is the general form of that plane. And we're also told the equation of this line. We're actually given the vector form for the equation of this line. I'll call this L1. So this equation is given as 1, 2, 5 plus t times 4, 5, 6. So we have the general form equation for the plane, we have the vector equation for the line, and this is enough information for us, believe it or not, to figure out this point of intersection. So follow along. The first thing you want to do is you want to take this vector equation and you want to turn it into a set of parametric equations. So for x, you would say x is equal to 1 plus 4 times t, right? 1 plus, and then you have 4 times t. You do the same thing for y and z. Y is equal to 2 plus 5 times t, right? 2 plus 5 times t. And you have z is equal to 5 plus 6 times t. Hopefully by now you know how to make these parametric equations from the vector form. Next, what you can do is you can take those definitions for x, y, and z, and you can plug them into this first equation, the equation of the plane. That's what I'll do. I'll say 2 multiplied by 1 plus 4t plus 2 plus 5t plus 3 times 5 plus 6t plus 1 is equal to 0. Okay, now we're going to expand all these brackets. 2 times 1 is 2, 2 times 4t is 8t, so 2 plus 8t. This bracket just stays the same. There is no coefficient in front of it. Over here we have 3 times 5 is 15, 3 times 6t is plus 18t, plus 1 is equal to 0. Now I'll collect some like terms. We have a 2, a 2, a 15, and a 1. Those will add up to 20. We have an 8t, a 5t, and an 18t. Together, those should make 31t. Let me scroll down here, and that's equal to 0, right? So now we can say 31t is equal to negative 20, or t is equal to negative 20 over 31. This is the value of t. We can use this to solve for x, y, and z because remember we said x was equal to 1 plus 4t, or 1 plus 4 times negative 20 over 31. We said y is equal to 2 plus 5t, or 2 plus 5 times negative 20 over 31. And we said z is equal to 5 plus 6t, or 5 plus 6 times negative 20 over 31. In each of these cases, we can do these calculations. For x, you should just get the answer negative 49 over 31. For y, you should get negative 38 over 31. And for z, you should get positive 35 over 31. So you can take those three values, and they will give you the point of intersection. The POI is equal to negative 49 over 31, negative 38 over 31, and 35 over 31, just like that. So if you're looking at your diagram up here, you can see this red point here does in fact have those coordinates. Now, it is possible that when you have a line and a plane that they won't intersect one another because the line could exist in a plane that is parallel to this plane here. And if that were to be the case, you would get a result while you're trying to figure this out that doesn't make sense. Just like how if you try to find the point of intersection of two lines, whether it be 2 dimensions or 3 dimensions, and you get a result that doesn't make sense. You get something like 2 is equal to 0. You get to a step in your calculation where it just doesn't make sense. And when that happens, it's because there is no solution, right? There's no point of intersection that you can actually find because the two things don't intersect one another. So it is possible you get no solution, but more often than not with lines and planes, there's a pretty good chance that they do end up intersecting each other like this one does here.